In experimental volcanology, creating analogues of bubbles in magma allows us to replicate volcanic processes and investigate how bubbles affect their behaviour. Currently, there is no standardised method for creating bubble suspensions in a way that would allow us to systematically control their characteristics, such as gas volume fraction. Being able to control the gas volume fraction means that during experiments we can investigate the effect that bubbles have on different processes, such as fragmentation, and how pyroclasts are formed and shaped. We create an isothermal bubble suspension by combining citric acid and sodium bicarbonate in golden syrup. The chemical reaction between the two reagents produces carbon dioxide bubbles. As the bubbles develop, they rise through the golden syrup to form a foam at the top. By adding different quantities of reagents, we can control the gas volume fraction that is generated. In later experiments, we aim to produce homogeneous bubble suspensions by continuously stirring the mixture while the reaction progresses. We introduce the use of cinder toffee as a magma analogue that undergoes a phase change from liquid to solid on cooling. Cinder toffee is solidified bubbly molten sugar that is created by mixing melted sugar with sodium bicarbonate. The sodium bicarbonate undergoes thermal decomposition and releases carbon dioxide, which forms bubbles that are then preserved as the mixture cools and solidifies. Like the isothermal analogue, we can produce cinder toffee that with different vesicularities by using different amounts of sodium bicarbonate. This allows us to investigate the effect that bubbles have on a material that undergoes a phase change. Here I've introduced these analogue materials and how they may be useful in experimental volcanology. Having a systematic and standardised method for creating these analogues is important for controllable and reproducible experiments.